balancing oxidation and reduction reactions. This is important because these redox reactions are everywhere, right? I mean, all combustion reactions are redox reactions. There's an exchange of electrons between reactants and products. What goes on inside an alkaline battery? It's the reason why your toothbrush works, right? These electrons are produced from a redox reaction and going from reactants to products. So it's kind of an interesting conversation here between a couple scientists. Yeah, we need a game plan, okay? And here it is. Here's our game plan. Now, we're going to go over this step by step, so I'm not going to read it here. But one thing you can notice is that there's 6 steps, and you only do the step 6 if you're in basic solution. So if the solution is basic, you have to do the step number 6. If the solution is acidic, we don't worry about step number 6, and you'll see that. So here's our game plan, written on the side over here. Let's try this. Balance each redox reaction, either acidic or basic solution. Now this is a basic solution, this first one. Is it even balanced? Let's just check. Here we have 4 oxygens. Here we only have 3 oxygens. All right? The charge isn't even balanced. This is really messed up. So how would you balance this? We have to follow the game plan. Otherwise it would just be too complicated to randomly put in numbers. The first step in the game plan, split the unbalanced equation into 2 half reactions. So what are those 2 half reactions? Cyanide going to CnO-. The other half reaction is permanganate going to manganese 4 oxide. Now, for each half reaction, let's do these steps. Let's balance all atoms but O and H. So, balance the carbon and the nitrogen, they're balanced. Balance the oxygen by adding H2O to the appropriate side. We have 1 oxygen, so we need to add 1 H2O. Balance hydrogen by adding H plus to the appropriate side. We have 2 hydrogens, so we better add 2 hydrogen ions. Balance the charge by adding electrons to the most positive side. Okay, this is sometimes confusing. To figure out the charge, just multiply the coefficient, the stoichiometric coefficient, times the charge. So here I have 1 times 0, so this is 0. Here I have 1 times a negative 1, it's a negative 1. So this whole side is a negative 1. This whole side, 1 times a negative 1, 2 times a positive 1. So this whole side is a positive 1. So add electrons to the most positive side. So I'll have the same charge on both sides. So I have a positive 1. If I add 1 electron, a negative 1 and a positive 1 is 0. Not enough. I need 2 electrons. So a negative 2 and a positive 1 is a negative 1. So now I have a negative 1 on both sides. So this top equation is balanced. So let's clean it up a little bit. Now we do all the same steps for the second half reaction. Balance all atoms but O and H. Manganese, manganese, 1 on each side. Balance O by adding H2O. I have 4 oxygens on one side, 2 on the other, so add 2 oxygens by adding 2 waters. Now balance hydrogen by adding H+. 4 hydrogens, so I better add 4 hydrogen ions. Now balance the charge by adding electrons to the most positive side. So on this side, I have 4 times a positive 1, positive 4, and a negative 1, a positive 3. Again, multiply the stoichiometric coefficient times the charge. So here I have 0 plus 2 times 0. This side I have 0. Add electrons to the most positive side, so I get the same charge on both sides. 3 electrons. Okay, now I have 2 balanced half reactions. So now we're on step 3. Multiply the half reactions so that the electrons will cancel. So you can't have electrons floating around. So let's clean it up a little bit. I'm going to multiply these half reactions by what? The top one by 3, the bottom one by 2, right? Because then I'll have 6 electrons will cancel. So multiply the top half reaction through by 3, the bottom one through by 2, and add everything up. So I'll have 3 waters plus 3 cyanides, 8 hydrogen ions, and 2 permanganates. We have 3 CNO minus, 6 hydrogen ions, 2 manganese 4 oxides, and 4 H2Os. Okay, let's try to simplify this a little bit. I've got 3 waters here. Let's cancel those out. Use 1 water. I have 6 hydrogen ions here, 8 here, so that leaves it with 2. Okay, that's about as simplified as I can get it. If this would have said acidic solution, we'd be done, but we're not. We're in basic solution, so we have to do this step 6. Convert all H pluses to water by adding an appropriate number of hydroxides to each side of the balanced equation. So I have 2 hydrogen ions, so I have to add 2 hydroxides over here. I have to add 2 hydroxides over here. Those hydroxides combine with the 2 hydrogen ions to make 2 waters. So I can write this, my final answer, but you notice how one of these waters is going to cancel. It's going to cancel with that water over there. So let's rewrite this so it's nice and neat. I'll have 3 cyanides plus a water, 2 permanganates, produces 3 CNO minus, 2 hydroxides, and 2 manganese 4 oxide. Here's my final answer. What I usually do is just make sure the oxygens are balanced, and then I'm probably pretty good. So I've got 9 oxygens on this side, and on this side I have 3, and 2 is 5, and 4, 9 oxygens. So I'd say it's balanced. Let's try this one. Break it up into its half reactions. Okay. For each half reaction, balance them. First, we balance everything but O and H. Balance O by adding H2O. I have to add 2 waters. Balance H by adding H pluses. 4 hydrogen ions. Now balance the charge by adding electrons to the most positive side. This side, I have 4 times a positive 1. I have a positive 4 and a negative 1, so I have a positive 3. Over here, I have 0. So I have to add 3 electrons, so I will have 0 on both sides. Coppers are balanced, no O's or H's, so all I have to do is add 2 electrons. I'll have 0 on both sides. Add them up. It's like I have to do the times 3 on the bottom, times 2 on the top. So my electrons will cancel. I'll end up with 8 hydrogen ions and 2 nitrates plus 3 copper produces 2 nitrogen oxide, 4 moles of water, and 3 moles of copper 2. Okay, can I simplify it? Nope. How about the oxygens? Are they balanced? I have 6 oxygens on this side, 2 and 4, 6 oxygens on this side. It's an acidic solution, so I don't need to add hydroxides. I'm done. Here's another basic solution. So I've got zinc going to this zinc complex. Balance everything but O and H. Done, because there's 1 zinc on both sides. Balance O by adding H2O. I have 4 oxygens, so I better add 4 waters. Balance H by adding H pluses. I have 8 hydrogens on the reactant side, only 4 on the product side, so I need 4 more. Now I have 8 hydrogens on both sides. Balance charge by adding electrons to the most positive side. Over here, 4 times 0 plus 1 times 0, 0. Over on this side, 1 times a negative 2 is a negative 2. 4 times a positive 1, positive 4. So overall, I have a positive 2. Add electrons to the most positive side to balance the charge. So plus 2 electrons. So that half reaction is done. Let's do the other half reaction. Nitrate goes to ammonia. The nitrogens are balanced. O by adding H2O, I need 3 of them. H by adding H plus. I have 3 and 6. I have 9 hydrogens on that product side, so I need 9 hydrogen ions over there. The electrons are the most positive side. Over here, positive 9 and negative 1, I have a positive 8. Over here, I have 0. So I have to add 8 electrons. So it looks like to balance this, I'm going to multiply the top one through by 4, the bottom one just by 1. So 4 times 4 is 16 water, 4 moles of zinc, and my electrons canceled. 9 hydrogen ions, a mole of nitrate, four moles of that zinc complex, 16 hydrogen ions, and a mole of ammonia, and 3 moles of water. Okay, let's see if we can clean this up a little bit. These 3 moles of water will cancel with that 16 and make that a 13. These 9 hydrogen ions will cancel with that 16 and make that a 7. That's about as cleaned up as I can get it. I'm in basic solution. So if I was an acidic, I could quit right now. But since I'm in basic solution, I have to add 7 hydroxides to both sides to convert all those hydrogen ions into water. So if I add 7 hydroxides to this side, I'd better add it over here too. Now these are going to produce 7 waters. Can I simplify that at all? Looks like those 7 waters will cancel out and leave 6 waters over here. So let's go ahead and rewrite this. I'm going to have 6 moles of water plus 4 moles of zinc plus 7 moles of hydroxide, mole of nitrate. It's going to produce 4 moles of that zinc complex, a mole of ammonia. Let's see if my oxygens have the same number of oxygens on both sides. Here I have 6 oxygens, and 7 oxygens, and 3. That's 16 oxygens. On this side, oh, yeah, I have 16 oxygens. So it worked. This one looks a little nicer, doesn't it? Zinc goes to zinc 2. So all I have to do is add 2 electrons on the product side. Nitrate goes to nitrogen. Okay, balance everything but O and H first. So I have 2 N's, so I better put at 2 N's. 6 oxygens, so I better add 6 waters. 12 hydrogens, so 12 hydrogen ions. Now electrons to the most positive side. Over here I have a positive 12 and a negative 2, positive 10. Over here I have 0. So I have to add 10 electrons. Okay, now I'm ready to add these up, but I have to cancel electrons. So multiply the top one through by 5, the bottom one just by 1. So I'll have 5 moles of zinc, and so the electrons are going to cancel. 12 moles of hydrogen ion, 2 moles of nitrate. It's going to form 5 moles of zinc ion, and a mole of nitrogen, and 6 moles of water. Let's check those oxygens. On this side, I have 2 times 3, I have 6 oxygens. Over here, 6 oxygens. I'm in acidic solution. I'm going to stop right there. First step, break it into its half reactions. Manganese, goes to manganese 4 oxide. 1 manganese on both sides, so oxygen by adding H2O, hydrogen by adding H+, electrons to the most positive side, positive 2, positive 4, so we're going to add 2 electrons over here. That way I have a positive 2 on both sides. So this half reaction is completed. Let's try the other half reaction. Chlorate goes to chlorine dioxide. Chlorine, not 1 chlorine on each side. I need to add 1 water. Now I need to add 2 hydrogen ions. This side is a positive 1. This side is 0. So I have to add 1 electron. So in order to add these up, multiply the bottom half reaction by 2, top one by 1. So my electrons will cancel. So I have 2 moles of water, manganese 2, plus 4 hydrogen ions, 2 chlorates. It's going to produce manganese 4 oxide, 4 moles of hydrogen ion, and 2 moles of chlorine dioxide, and 2 moles of water. Let's try to clean this up a little bit. It's like my water will cancel out. My hydrogen ions cancel out. Great. So I'll have manganese and 2 chlorates produces manganese 4 oxide and 2 chlorine dioxides. It's in basic solution, but I don't have any hydrogen ions to add hydroxide to. So let's just check and see if the oxygens are good. I have 6 oxygens. 2 plus 4, 6 oxygens. Looks good. So the name of the game here is pretty much this game plan. And just be familiar with it, take it one step at a time, and make sure you follow these steps in the exact order that's given. And if you do it enough, you'll get used to it. Good luck.